Hey everyone, so here we go, another video, this time on waves. So I'm introducing you to what waves are. So waves, what is a wave? So I have here two videos which I'll put in the description for you. One is just to give you an idea or starting to think about properties of waves. So I'm asking what is the surfer riding? Hard question. And then the other one is, people say that that wave is huge. It's actually not the biggest wave ever surfed. So then I put another video for your interest only on where you can see the actual biggest wave that was ever surfed. But then the guy, the surfer, Garrett McNamara, I think that's his name, at the end he's saying how he felt about the wave, and I want you to think about this. So the wave was pretty tall, and he says that he felt like tons of energy and all that stuff. So this is going to be important for our next video. So maybe the height of the wave has to do with something else. Anyway, on the waves. So waves, what waves are some waves? Other examples of waves between of the ocean, besides of the ocean waves, you can get this wavy pattern from a slinky or flag. So all of these are waves. There are other types of waves, okay? A wave is anything that is a disturbance moving through a material, okay? Waves are vibrations that transfer energy and information from place to place without matter, solid, liquid, or gas being transferred, okay? So when I'm talking, I am sending vibrations throughout the medium, which is going to be the air, the gas, and this is going to the microphone. So I have the energy and the information being sent out because the particles in the medium where I'm talking are vibrating and passing these vibrations on. Think a little bit like the football waves, the Mexican wave in a football stadium. So you have the football crowd, and the waves, if you get the people making the wave moves around the stadium, while each spectator stays in their seats, only moving up and down when it's their turn. Is the same with the waves. So I'm not transferring the solid, the liquid, or the gas. I'm only having the vibration to happen, but then after the vibration, after the disturbance, the materials or the solid, liquid, or the gas, the particles are where they were before, okay? So this is what a wave is. Now, waves can be mechanical or electromagnetic. Mechanical waves are vibrations that travel through a medium, a substance. So medium is the substance where they travel through. Electromagnetic waves all travel at the same speeds, 300,000 kilometers per second or 300 million meters per second. They travel through a vacuum and no medium is needed. So this is how I get, for example, heat from the sun getting to the earth. So mechanical waves, the ones that need a medium, there are sound waves, water waves, waves on springs and ropes, seismic waves, so the waves for the earthquakes. All of these are mechanical waves. Electromagnetic waves are, for example, gamma rays, X-rays, ultraviolet, visible light, which are the light waves, infrared, microwave, and radio waves. More stuff will come on electromagnetic waves, okay? And as I told you, they all travel at the same speed, the electromagnetic waves, and they do not need a medium to be able to travel through. Okay, now waves can also be either transverse or longitudinal according to how they move through the medium or the no-medium. So according to how they move across the place where they're moving. So in transverse waves, the vibrations are at right angles, so perpendicular to the direction of travel. If you see this example with the rope, the disturbance is going up or and down, but the wave is going from the hand to the end of where the rope is showing. So the disturbance is moving up and down, so the vibrations are up and down, but the waves, the direction of the energy travel is from left to right, okay? Waves can also be longitudinal. The example is if you kind of push a slinky. In longitudinal waves, the vibrations are along the same direction as the direction of the energy transfer or the direction of travel. So here we go. I kind of give a kick to the slinky, and you have places where the wave is further from each other, or I don't want to use a keyword yet, but anyway, the wavelength is longer. Other times where I have some compressions, so these are called compressions, these are called rarefactions, and I can see that the wave actually I shouldn't even have said wavelength is longer, but it doesn't matter, you're going to learn in another video. But I can see the disturbance passing through not perpendicular but parallel to the direction of travel, okay? So just to make sure that we know about mechanical, electromagnetic, transverse or longitudinal waves, I just made up some waves in here and I want you to decide if they are transverse or longitudinal according to how they move, or and if they are mechanical or electromagnetic according to if they need a medium or not. So pause the video because the answers are going to show now. So if you want to try, pause the video first. The football waves, the Mexican wave, people move up and down, so it's a transverse wave, and there is no Mexican wave if there are no spectators, so it's a mechanical wave because you need a substance to send the vibrations on. Light waves, they are part of the electromagnetic radiation, so they are transverse waves, and they are electromagnetic because they do not need a medium to travel. And you know that because you get light from the sun, and in between the sun and the earth, pretty much you get a vacuum, okay? Electromagnetic radiation, so all waves in the electromagnetic radiation are transverse and electromagnetic, so not much to say about this one. Sound waves, they are longitudinal, they travel along the same line where vibration started, and if there is vacuum there is no sound, so they are mechanical as well, okay? Now, standing on a line or a queue, imagine that you are on a line, you wait for the person in front of you to move and you move forward. So that's an example of a longitudinal wave because your movement, your vibration would be in the direction that the energy is traveling or the wave is traveling. So that would be longitudinal. No people on the queue, no queue, so it's a mechanical wave. Seismic P waves. Now, seismic waves, they need a medium to pass through, so they will be mechanical. The seismic P waves, they move parallel to the direction of energy transfer, okay? So in case you didn't know, that's what happens. Seismic S waves, they are different. Although they still need a medium to pass through, they move up and down. So they are transverse waves, okay? So transverse and mechanical. And finally, water waves. Well, they move up and down, so they are transverse waves. No water, no waves, so they are mechanical as well, okay? So I hope this is making more sense about if a wave is transverse, longitudinal, mechanical, or electromagnetic. I have more questions though. This is a net transverse wave. What type of energy is that wave transferring? So the wave is moving is kinetic energy. In which direction is the energy moving? So it's going to go from left to right. In which direction is each part of the rope moving? Because it's a transverse, is perpendicular to the direction of energy transfer. So it's up and down. And state one type of wave that is transverse and mechanical. You could have said waves on a rope, for example, okay? Another exercise, longitudinal waves. So this one already says one of the things. So what type of energy is the wave transferring? Is moving still, so it's kinetic. In which direction is the energy moving? The same as before, it's still going from left to right. In which direction is each part of the wave or the spring moving? Sideways, parallel to the direction of energy transfer, so it is a longitudinal wave. When a sound wave passes through the air, what happens to the particles? At a compression, they get closer together. So compression, the parts of the wave are closer together. Rarefactions, they are further apart. There is a link there for a video. I'm also going to add that in the description. Is a video that I don't think anyone is talking, or if they are, is like no visual stuff besides of the writing of what is going on. Pretty much a video like mine, but a shorter one is only 3 minutes. Now, more exercises about waves. Complete the sentences. Waves transfer energy and information. Waves may be either transverse or longitudinal. Electromagnetic waves are transverse, sound waves are longitudinal. Mechanical waves may be either transverse or longitudinal. All type of electromagnetic waves travel at the same speed through a vacuum. Longitudinal waves show areas of compression and rarefaction, okay? So this is all that you needed to know about waves. I still have another exercise, I think, so I'll show you. On this part, mechanical waves can either be transverse or longitudinal. Of course, that's true. Electromagnetic waves are all transverse, okay? So, write a short text explaining waves using all the words below. And I have vibrations, mechanical, transverse, parallel, medium, energy, perpendicular, transfer, electromagnetic, longitudinal, sound, and information. So, pause the video if you don't want to see the answer just yet. Otherwise, here's the model answer. So, we use waves to transfer energy and information. Transverse waves vibrate perpendicular to the direction of energy transfer. All electromagnetic waves are transverse. Longitudinal waves vibrate parallel to the direction of energy transfer. Sound waves are longitudinal waves. And finally, mechanical waves need a medium, a substance, to travel through and may be transverse or longitudinal. So that is it about waves, so the introduction of waves. Up to my next video. Be happy and healthy. Bye!